This is an intro to solving limits with an indeterminate function. So just to recap, a limit is basically the value of a function as x approaches a certain constant. So in this case, we're finding the limit as x approaches 3 of x minus 2 over x squared minus 4. And so to solve a limit, all you do is plug the value that x approaches into the function. So in this case, when you plug in 3 into the function, you get 3 minus 2, which is 1, over 3 squared minus 4, which is 6 minus 4, which is 2. So our final answer would be 1 over 2. And so that's how solving a limit the easy way is done. You simply plug in the value that x approaches. Now, say you plug in a value, and you get something else. For example, in this case, when you plug in 2 into the same function, you get 2 minus 2, which is 0, over x minus 4, which is 4 minus 4, which is 0. And so in this case, you get 0 over 0. And we know that dividing by 0 is not possible. But the answer to this is not undefined. It's actually something else. If you get 0 over 0 after solving a limit, this is actually called an indeterminate function. And there's actually another way to solve this. When you get 0 over 0, the answer is probably not going to be undefined. It's probably going to have a specific value to the limit. So what I mean by that is you need to manipulate the function so that you get a certain value. So in this case, we can manipulate it algebraically to get the value. And if you know the identity a squared minus b squared equals a minus b times a plus b, you can apply that to this function. So if we apply that, we get x minus 2 over x minus 2 times x plus 2, because x squared minus 4 is equal to x minus 2 times x plus 2. And now once you do that, we simply find the limit of this as x approaches 2. And we see that x minus 2 cancels out from the numerator and denominator. And we're left with the limit as x approaches 2 of 1 over x plus 2. And again, all we do to solve a limit is plug in the value. So we get 1 over 2 plus 2, which is 4. So our final answer is 1 over 4. And so that's what solving limits with an indeterminate function looks like. You get a value in the form of 0 over 0, which is the indeterminate form, and you manipulate the function so you get a real number. And just to let you know that any constant that is not 0 divided by 0 is not indeterminate. So what I mean is 7 over 0 is not indeterminate. The indeterminate form is only 0 over 0. And if you get any other value, like negative 1 over 0, that's not indeterminate. So if you plug in the value that x approaches into a certain function, and you get something along the lines of a constant over 0, the answer is going to be undefined. There is probably no other way to solve that limit. So in this question, we have find the limit as x approaches 2 of the function x cubed minus 8 over x squared minus 4x plus 4. And so our first step is always to plug in the value that x approaches. So when we plug that in, we get 8 minus 8 over 4 minus 8 plus 4. And so we get our indeterminate form 0 over 0. And so now that we know that this is an indeterminate function, we know that we need to manipulate this in some way. And if you look at this function, you'll notice that you can use an algebraic identity for the numerator. and that identity is a cubed minus b cubed. So in this case, a is x and b is 2. And so you can rewrite this as x minus 2 times x squared plus 2x plus 4. And if you simply rewrite the denominator, you can write x minus 2 the whole square. And that's coming from a minus b the whole square. And so when you rewrite this in this way, you can see that the x minus 2 cancels out from the numerator, leaving you with only one x minus 2 in the denominator. And so when we cancel that out, we get x squared plus 2x plus 4 over x minus 2. And so now we can simply find the limit as x approaches 2 of this function, which is again equivalent to the original function. All we did was a simple manipulation. And so now when you plug in the value 2, you get 4 plus 4 plus 4, which is 12. And when you plug 2 into the denominator, you get 2 minus 2, which is 0. And so you might be thinking, well, we can't divide by 0. And that's right, we can't divide by 0. And so the answer to this would be undefined, or it does not exist. Would be better, does not exist. And so remember, the indeterminate form is 0 over 0. 12 over 0 will simply lead to a value that does not exist. Now in this question, we have the limit as x approaches 1 of x cubed minus 1 over x to the power of 4 minus 1. Now, our first step is always to plug in the value that x approaches. And here we can simply see that both the numerator and the denominator go to 0 over 0. So you get the indeterminate form. And now all we need to do is simple manipulation, algebraic manipulation. We can use the same identity, a cubed minus b cubed, for the numerator. And you can rewrite this as x minus 1 times x squared plus x plus 1, the whole over x minus 1 times x cubed plus 1. And so now you can see that x minus 1 can easily factor out. And so we're left with the limit as x approaches 1 of x squared plus x plus 1 over x cubed plus 1. And now we can simply substitute 1 into the function. And if you do that, we get 1 squared, which is 1, plus 1, plus 1, which is 3, over 1 plus 1, which is 2. So our final answer is 3 over 2. Now in this question, we have find the limit as x approaches 1 of the square root of 2x plus 3 minus the square root of 5, the whole over x minus 1. Now, our first step is to plug in the value that x approaches. So you get 1 times 2, 3 plus 3, which is the square root of, actually 1 times 2 is 2 plus 3 is 5, square root of 5 minus square root of 5 over 1 minus 1, meaning both the numerator and denominator both go to 0. So we're left with the indeterminate form, 0 over 0. Now in this case, if we take a look at it, it's evident that we can't use any identity to cancel anything out. And so you might be asking yourself, how do we rewrite this? How do we manipulate it? Well, this question requires us to use our knowledge of conjugates. We need to multiply by the conjugate of the numerator. And so this is how you do that. 2x plus 3 minus the square root of 5, and use brackets in my opinion, times the square root of 2x plus 3 plus the square root of 5 over x minus 1 times the square root of 2x plus 3 plus the square root of 5. And now if you're asking yourself, how did I know to do this? All I did was multiply by 1, because the square root of 2x plus 3 plus the square root of 5 divided by the same thing is just 1. And so all I did was multiply the original function by 1. Now why did I choose this specific value? It's because if I choose the conjugate, which is simply replacing the sign in the middle of the two terms, so in this case the negative becomes a positive, you're able to cancel out the square roots. And when you cancel out the square roots, it usually makes it defined, and you can plug in the value that x approaches. So a key term to remember is that whenever you have a square root in the function, you can try multiplying by the conjugate, so you can cancel out certain things. And so when we multiply through, we can get 2x plus 3 times 5. Or no, 2x plus 3 minus 5 over x minus 1 times the square root of 2x plus 3 plus the square root of 5. Now, if we simplify the numerator, we get 2x minus 2. Actually, I'll write this as 2 times x minus 1. You'll see why later. And we can write x minus 1 times the square root of 2x plus 3 plus the square root of 5. Okay? And so now we can see that x minus 1 cancels out. Okay? And so we're left with the limit as x approaches 1 of 2 over the square root of 2x plus 5 plus the square root of 5. Right? And now if we substitute 1 into this function, we should get our answer. So we get 2 over 2 times 1 is 1, and 2 plus 5 is 7. So the square root of 7 plus the square root of 5. And so we can leave our answer like this. Or if you want, we can multiply the numerator and the denominator by square root of 7 plus 5. So or square root of 7 plus square root of 5. So you can cancel out the square root in the denominator. But this should be fine. So in this question, we have find the limit as x approaches 4 of the square root of x plus 9 minus the square root of 13 over x minus 4. So again, our first step is always to plug in the value of x, the value that x approaches. And when we do that, we get the square root of 4 plus 9, which is 13, minus the square root of 13 over 4 minus 4, which is 0, over 0. Now that we know that the function is indeterminate, we know that we can manipulate the function a bit more. Since I see a square root in the numerator, I know that I can multiply by the conjugate to get a good canceling out of terms. So get square root of x plus 9 minus the square root of 13 times the square root of x plus 9 plus the square root of 13 over x minus 4 times x plus 9 plus square root of 13. Right? And now if we solve for this, we get, I'll write this down here, we get x plus 9 minus 13 over simply the same denominator, x minus 4 times the square root of x plus 9 plus the square root of 13. And now we can simply simplify the numerator, and we get x minus 4 over x minus 4 times the square root of x plus 9 plus the square root of 13. And so we see that x minus 4 cancels out, and the function is simply 1 over the square root of x plus 9 plus the square root of 13. And we can simply find the limit as x approaches 4 of this now manipulated function. And so now all we do is plug in the value that x approaches, and we get 1 over square root of 13 plus the square root of 13, which is 2 times the square root of 13. And so this is our final answer. So in this question, we have find the limit as x approaches 0 of x squared sine of 1 over x squared. So when you plug in 0, you get 0 square root of 0 times sine of 1 over 0. And so looking at this, we see that sine of 1 over 0 does not exist because you can't divide by 0. And it's not indeterminate because it's not 0 over 0. But in this question, we have a sine. And there's actually a quick method to solving for a limit with either sine or cosine that isn't defined, or you can't find the value of it because you're dividing by 0. And so this is actually called something called the squeeze theorem. It's called the squeeze theorem. And it's actually pretty easy to understand, the squeeze theorem. All we're doing is basically constraining sine. And what I mean by that is we know that sine of x cannot be less than -1. And it cannot be greater than 1 as well. Right? And we also know that sine of 1 over x squared, therefore, cannot be less than -1 and greater than 1. Right? That's easy to understand as well, since sine of x is never less than -1 and never greater than 1. And so using this information, we can actually manipulate this function. So what I mean by that is, if we multiply all of these terms by the same variable or constant, that's legal, or that's acceptable to do. So in this case, if we multiply all of these terms by x squared, by x squared, you get -x squared is less than or equal to x squared sine of 1 over x squared is less than or equal to x squared, right? And so this is our original function. Our original function was x squared sine of 1 over x squared, right? And now we know that it's always greater than or equal to negative x squared and always less than or equal to x squared. And so what the squeeze theorem states is that if a function, in our case the function is x squared sine of 1 over x squared, is in between two separate functions that have the same value when you plug in a limit or a value that x approaches, the value of the original function will be equal to the value of the limit on its left and right, or top and bottom. And so graphically, this would look something like this. Imagine this was g of x, and this was h of x, and f of x is somewhere here. F of x is squeezed in between g of x and h of x. So you know that f of x at that point where it's squeezed is equal to the value of h of x and g of x at that point. And so using that principle, we know that since our original function x squared sine of 1 over x squared is greater than or equal to negative x squared and less than or equal to x squared, we know that this represents g over x. This represents our original function f of x, and this is h of x. And so we know that if we plug in the value that x approaches into this, into g of x separately and h of x separately, and they're equal, that means that x squared sine of 1 over x squared is equal to that value. And so let's see what we get. If we plug in 0, because at x is approaching 0, if you plug in that into this equation, we get 0 is less than or equal to x squared sine of 1 over x squared is less than or equal to 0 squared, which is 0. And so we know that as x approaches 0, the limit of x squared sine of 1 over x squared is 0, because g of x and h of x are both 0 at that point. So our answer to this question is actually 0, not undefined. And so that's a mini lesson on the squeeze theorem. In this question, we have find the limit as x approaches 0 of x cubed cosine of 1 over x. And so when we plug in our value that x approaches, we get x cubed, which is 0, times cosine of 1 over 0. We know that we can't divide by 0, so we know that it could be undefined. And like I said before, we can use the squeeze theorem to solve for functions that have cosine or sine, or any trigonometric function that has a certain bound. So just like sine, we know that cosine of x is bounded by negative 1 and 1. We know that it's less than or greater than negative 1, or no, greater than or equal to negative 1 and less than or equal to 1. And using that same principle, we can infer that cosine of 1 over x is greater than or equal to negative 1 and less than or equal to 1. And like before, we can multiply all of these terms by x cubed, because that's acceptable if you multiply all of them by the same value. You get negative x cubed less than or equal to x cubed cosine of 1 over x is less than or equal to 1. No, not 1, x cubed sorry. And so all we need to do is plug in 0, which is what x approaches in this case, into this equation. So we get negative 0 cubed, which is 0, is less than or equal to x cubed cosine of 1 over x is less than or equal to 0 cubed, which is 0. And so now we know that if this represents g of x, and this represents h of x, and this represents f of x, our original function, which matches this original function, we know that our answer to this question is 0. So that's the answer to this question using the squeeze theorem. So now in this question we have find the limit as x approaches 2 of 1 over x minus 1 over x plus 3, the quantity over x minus 2. And so now looking at this, we can plug in 2 into this function. We get 1 over 0 minus 1 over 0 over 0. This looks like the indeterminate form to me, right? 0 over 0. And so we know that we can manipulate this function slightly to get a certain value. In this case, we know that we can't solve algebraically using an algebraic identity, or we can't multiply by the conjugate because there's no square root, and we can't use the squeeze theorem because there's no trigonometric function. In this case, we'll do something different, and we can actually find the common denominator in this case. So if you find the common denominator in this case, we simply find the common denominator for the numerator. So in this case, we have a common denominator of x times x plus 3. So we can write x times x plus 3, and we get x plus 3 minus x. And this is, never forget the original denominator, which is x minus 2 in this case. And so now we can simplify this a little. We get x minus x, which is 0, and we get 3 over x times x plus 3 times x minus 2, right? And so now we can try to plug in our value, which in this case is 2, because x is approaching 2. We get 3 over 2 times 2 plus 3, which is 5, times x minus 2. And so, x minus 2 is actually 2 minus 2, which is 0. So 3 over 0. And we know that any constant that's not 0 divided by 0 is simply undefined, or does not exist. Remember, any constant that is not 0 divided by 0 is always undefined. It needs to be 0 over 0 to be indeterminate. So in this case, we have find the limit as x approaches 1 of 2 over x minus 2 over 1, the whole over x minus 1. So in this question, you can see that 2 over 1 is simply 2. But I think the question is worded in this format so that we know that we need to take a common denominator. And so usually you won't find it in this format where it's 2 over 1. You need to use your intuition to figure out that you need to find a common denominator for the numerator. So in this case, we find the common denominator for the numerator by using x as our denominator. We get 2 minus 2x over x, the whole over x minus 1. Now if we simplify this a bit, we get 2 times 1 minus x over x times x minus 1. And so we can see that 1 minus x and x minus 1 are almost the same, except that you need to multiply one of them by negative 1 to get the same expression. We can simply take a negative 1 outside from this top 1 minus x, and we get negative 2 over x, x minus 1, x minus 1. And now we can clearly see that, or sorry, it's actually x here, my bad, not 3. So x minus 1 cancels out, and we're left with negative 2 over x. And if you find the limit of this, find the limit as x approaches 1, we get negative 2 over 1, which is negative 2. So our final answer is negative 2. So this video was aimed at helping you solve indeterminate functions as x approaches a certain value. Again, just to recap, an indeterminate form is 0 over 0. 7 over 0, for example, is not indeterminate and can never be, you can never find the limit of that. And the various methods I used in this video were first using algebraic identities to solve the limit of an indeterminate function. And the second method I taught you was multiplying by the conjugate. The third method I taught you was only in the case of trigonometric functions, and that's using the constraints and the squeeze theorem. So that's squeeze theorem. The fourth and final method I taught you was simply finding a common denominator. So these are some of the most common ways to solve limits of an indeterminate function.